Hey there, ladies and gentlemen, boys and girls. Today we're going to talk a little bit about how to calculate acceleration using a velocity time graph. All right, so we're going to put on our math caps on, and we're going to think a little bit about calculating slope. All right, we're going to do 3 examples here. So first, I'm going to show you how we come up with the formula, which should look familiar. It's very similar to the formula we use for acceleration, for velocity. I'm going to show you how to do it. We'll do a couple of examples, talk about the units, which is a very peculiar units, which a lot of students make the mistake on, and we'll kind of recap there. All right, so make sure you guys have your handy dandy notebooks out. In fact, right now I take a second and pause it so you can copy down that graph nice and big. We'll do all 3 of those lines, so take a moment to do that. I'll give you a second. Okay. So let's talk about what it means to be acceleration. So let's just talk about conceptually, big picture, and then we'll talk about the math part. All right. Now remember, we have a velocity time graph. Now velocity is speed and direction. So we have the numbers for our speed, but we have those positives and we have those negatives. Positive up here and negative up here, or down here, that shows us our velocities. Right. So at the very beginning, a couple weeks ago, we started with just like this green line where the speed was staying the same. Staying the same speed in the same direction. That was constant velocity. But now we have ones like the blue and the red where the speed is changing. We can even have changing in direction. In this case here, we have this blue one here. We're starting at 0 speed, and we start going all the way up to about 4 meters per second. The speed is gradually increasing, right? Speed is increasing. That means we are accelerating. There are 3 ways to accelerate: speed up, slow down, or change your direction because you're changing your velocity. So remember, acceleration is a change in velocity. Remember, that triangle means change. So acceleration is a change in velocity. If you're speeding up, slowing down, or changing your direction, you are accelerating. And so our formula is going to show that. All right? To calculate acceleration, all right, we are going to calculate the change in velocity, in this case, over time, because none of this could happen. No motion can occur without time progressing. All right? If I pause the video right now, I can't be in motion because I'm paused. All right? Time has to be progressing forward. So it's a change in velocity over time. So to get my formula, just like we did before, it's going to be the slope of the line here. All right? So on this velocity time graph, acceleration is going to be equal to the slope. So right here we said that there's no change in velocity, no slope, no acceleration, that green line. But both the blue and the red line have a slope, which means they are accelerating. All right, so if we find that slope, we find the acceleration. And we know slope is a change in the y-axis, velocity, divided by the change in the x-axis, time. So the way we would do this here, all right, we would do acceleration. So here we're going to do our formula right here. Acceleration, which we always use a lowercase a, all right, is a change in velocity, which is the y-axis, divided by a change in time. Right? Now we talked about this before. Just like in math class, change in y over change in x, that's actually, you have to take 2 points. Math class, we said it'd be like y2 minus y1 divided by x2 minus x1. All right, but we're not using x and y, we're using velocity and time. So in this case here, what I have is the final velocity. So I have little v for velocity, the final velocity, minus the starting velocity, So final speed and direction minus the starting speed and direction divided by the final time minus the starting time. And there's our formula. Acceleration is equal to the change in the speed and direction divided by time. So now we'll do a couple examples here. All right? Give me a second to kind of catch up. Now remember, when we are doing this, you need 2 points. You need a final velocity and a starting velocity, which means you need to pick 2 points. If it's a straight line, doesn't matter which 2 points you pick. I always pick the ones that are kind of the easiest to look at. All right, so let's do this blue one first. That's why I'm going to use the color blue to match that here. The acceleration on this. To do that, I need to find the slope. So the acceleration of this one, I'm going to pick 2 points. I'm going to pick this one right here to be my final. And I'll pick the starting one, because if you have 0, 0, that's just the best way to go. I'm going to pick that one as my start. All right, so it's going to be my final velocity. So velocity is the y-axis. My final one, bringing it over, it's positive 4 meters per second. Don't lose those units. It's going to help at the end, especially these ones. Minus my starting velocity, 0 meters per second, divided by my final time, 8 seconds, minus my starting time, 0 seconds. So it's positive 4 meters per second in 8 seconds. Okay, before we even reduce about this, what this is saying is I changed my speed by 4 meters per second in the positive direction in 8 seconds. I am changing my speed and direction by this amount every 8 seconds, which of course I can simplify. Positive 4 divided by 8. Do the math. I'm going to do it right this time. 0.5. All right, but now the units. Here's our units right here. Just so take the numbers. We just did the numbers. Here are our units. Meters, that's how much I changed my speed, meters per second, every second. Meters per second per second. So I changed my speed 0.5 meters per second every 1 second. Because we're not changing position here, we're changing speed. I went 0.5 meters per second faster every 1 second. I am changing my speed. In this case, I am speeding up, which we would see here. This line here shows an object's speed is getting greater. It is speeding up by 0.5 meters per second every 1 second. So after 2 seconds, it's going 1 meter per second. After 4 seconds, it's going 2 meters per second. After 8 seconds, it's going 4 meters per second. Every second it's going half a meter or 0.5 meters per second faster in this case. All right? Compared to green. So green right now we would say it's going at a constant speed. Well, a constant velocity, right, means no change. 0 change, which would mean 0 acceleration. But let's look what that math would look like real quick. I picked 2 points. I'm going to pick this one as my final. And, I'm going to pick, I'll pick this one right here as my start. My y-intercept there. All right? So it's going to be my final speed, which is positive 3 meters per second, minus my starting speed, which was also positive 3 meters per second, My final time was 8 seconds. My starting time was 0 seconds. So my speed, 3 minus 3, my speed changed 0 meter per second over that 8 seconds. 0 divided by 8 is 0 meters per second. That's how much my speed changed every second. My speed changed 0 meters per second every second, which makes sense. My speed did not change over this 8 seconds. I was going at a constant speed. Now, my constant speed was 3 meters per second, and I was staying at 3 meters per second. But remember, acceleration is how much did I change that speed? I did not change my speed here. My blue one, this is how much I changed my speed every second. That can be a little bit tricky. All right, let's try this last one here. All right, the acceleration. I'm going to pick this one as my final. I'll pick this one here as my start. So my final speed here, did I do that right? There we go, is negative 4 meters per second. That doesn't mean slow. That negative just means in that direction. So I started at negative, moving at 4 meters per second in the negative direction, minus my starting speed, which was negative 1 meters per second. Now I put in parentheses there because there's a negative subtracting, so it makes it clear. All right, I would make these pluses. Math class. All right, my final time is 3 seconds. My starting time is 0 seconds. So negative 4 minus negative 1, which would be pluses, would be negative 3 meters per second in 3 seconds, or negative 1 meter per second per second. My speed changed 1 meter per second every 1 second. It changed 1 meter per second per second. All right. Now, here's one thing I want to talk about real quick. All right, is these units here. These are the units, right? For accelerations, meters per second per second. I like using the words meters per second because it doesn't throw people off. But I want to tell you right now, you're going to see it written a different way. There's another way that some people will write it. What they will do is they will say, okay, a meter per second per second. So here's just a little note. The meter per second is the same thing. If I do a little bit of the algebra, right, because that's a meter per second times 1 over seconds, there's some fractions there. It's the same thing as saying a meter per second squared. Both of these are the correct units. Both of these are correct. I don't like using this one right here at the squared because all it is a second fraction of the top divided by a fraction that multiply them, that makes second squared. I don't like using that one because then everyone sees the squared and starts squaring numbers. And all of a sudden, everything is squared. It's 0.5. I have to square that number because it's per second squared. That's not the case. All right? It's just a unit. So another way I could write this one right here is positive 0.5 meters per second squared. If that feels confusing to you, what I just did, then don't do it. I just want to give you a heads up. All right, stick with the meters per second per second. I recommend it. And my experience, I like doing it that way because it seems to be less confusing. But I want you to be aware where that second squared comes from because it's a meters per second per second. Okay, I know there's a long video there because I wanted to make sure I get over a lot of things. Got to do a lot of the math, talk about the unique units. If you didn't feel like you got it, go back at it. Watch it again. All right? Otherwise, thank you guys for watching. Good luck. May the science be with you.